Hello, Algebra, and welcome to Lesson 2 of Unit 1, where we're going to continue solving equations, but we're going to look at a little bit more advanced equations. The main difference that we're going to be focusing on is having variables on both sides of the equal sign. We'll also look at equations with no solutions and infinitely many solutions, and be able to tell the difference between them. So, in the last lesson, we learned how to solve equations with a variable on only one side of the equal sign. What happens when there is a variable on both sides? Well, let's take a look. So you may know how to do this already, and if you do, great. But we need to get our variables together. Usually the very first thing we want to do, unless we got some maybe distributive property or combining like terms, but once we get two expressions completely simplified down, we want to combine or get our x's together or our variables together. So in this case, I'm going to move the 6x to the other side. So what I'm going to do is I'm going to add 6x to both sides. And what that's going to leave me is 7 on the left. 5x plus 6x is 11x plus 29. And then subtract 29. 7 minus 29 is negative 22. Now I want to move the 11 and separate it from the x. Oops, sorry. Divide by 11. Negative 22 divided by 11 is negative 2. All right, so we're basically doing the same thing we did last lesson, except we aren't just moving numbers, we're also moving variables. Now there's a tip that I'm going to give you here. And I'm going to refer back to some things that we just did in this problem. If we're moving a whole term, so for example, the negative 6x. So we move that whole thing to the other side of the equal sign. To do that, we either add, in this case we added because it was a negative 6x, or subtract. And we do that if it's a positive 6x. So if we're moving the whole thing, we're not splitting up the negative 6 from the x. We're not separating negative 6 and x yet. We're moving that whole thing to the other side. When you're moving the whole thing, you want to add or subtract. If you're splitting up a term, okay, for example, the 11x. So what we did here, we wanted to split the 11 from the x. You use multiplication or division. So in this case, in the problem above, we divided by 11, but you could also multiply if your problem is showing multiplication or division. Okay, so let's do a few practice problems with this. If you think you get it, like I said in the last video, pause it, try it, and then watch and see if you get it right. If you want to see a couple, keep watching. So I've got an x on the right and the left. So I'm going to get them together. I like to move the smaller one, or I guess not always the smaller one. I like to try to keep things positive. Okay, so I'm going to move the smaller x to the bigger x to keep things positive. So I'm going to move this x by subtracting x from both sides. So 6x minus 1x is 5x. Minus 5 equals positive 15. Add 5. Then we get 5x equals 20. Divide, because we're splitting it up now, and I get x equals 4. Okay. Now, I talked about earlier in this video how typically the first thing we do is get our x's together, but in this case, those x's are kind of blocked by the parentheses. So in this case, we do have to distribute first. So I'm distributing a 4, and on the right side, I'm going to distribute a 3. So I'm going to get 4x minus 24 equals 3x plus 3. Now the x's are unlocked. I'm going to get the x's together. So I'm going to move the whole thing by subtracting 3x. 4x minus 3x is 1x, or I can just write x. You can put the 1 in front if you want, but you don't have to. Minus 24 is still there, equals 3. Finish this up. I'm going to add 24. And I already have x by itself because there's a 1 in front of it. I get x equals 27. Okay, the next one is called a proportion. With proportions, which are a fraction equal to another fraction, what you're going to do is you're going to cross multiply. Now I'm going to go a little slower on this one to show you what I mean by cross multiply. I see x minus 1 divided by 9. To undo that multiplication or that division, I'm going to multiply both sides by 9. And that's going to cancel the 9 here. And that's going to give me x minus 1 equals, and I'm going to take 9 times the whole numerator. So 9 times x minus 4. But then I've still got that divided by 6. So I can't really do anything yet because I've got that 6 there. So I'm going to go ahead and get rid of the 6 by multiplying the 6. So I'm doing 6 times x minus 1. And I got to do 6 times the whole thing, x minus 1 equals 9 parentheses x minus 4. So I'm going to take a second to stop, and I want you to see what just happened. So the 9 and the x minus 4 are being multiplied together. Then the 6 and the x minus 1 are being multiplied together. So rather than doing all of this work here, I can go straight to cross multiplying. That's where you've probably done it before, but I wanted to show you why it works. Okay, so now we're at a spot. Once we cross multiply, we're at a spot that looks just like number 2. So I'm going to continue this problem to finish it up. So I'm going to distribute the 6. I get 6x minus 6 equals 9x minus 36. Again, I'm going to keep this positive, so I'm going to move the 6x to the other side. You won't have to keep it positive. It just makes life a little easier. So I get negative 6 on the left. 9x minus 6x is 3x minus 36. Add 36 to both sides. Negative 6 plus 36 is 30. Divide by 3 to split the 3 and the x. I get x equals 10. Okay. And then the last one here on this side, before we go to the back, kind of complex. It's got the distributive property in there. It's also going to have to combine like terms. Haven't done anything with the 3x yet. Negative 4 times x is negative 4x. Negative 4 times positive 2 is negative 8. 5x plus 12 hasn't been touched on the right-hand side. I have these two that could be combined. Remember, I'm not adding 4x because they're on the same side of the equal sign. 3x minus 4x is negative 1x minus 8 equals 5x plus 12. Now, negative 1 is smaller than 5, so you would think move it to the other side, and you'd be correct. I'm going to move negative 1 to the other side, but this time, instead of subtracting it, I have to add 1x. So I get negative 8 equals 6x plus 12. Subtract 12 now. I get negative 20 equals 6x. Divide by 6 and you get a nasty number. I don't want to see decimals. Remember that. Don't want to see decimals. Reduce that fraction. I know I can take 2 out of both 20 and 6. So negative 20 divided by 2 is negative 10. 6 divided by 2 is 3. And that is my answer. Okay, so we're getting a little more complex with our equations. Practice that. You got to practice to get better. Now let's move to the back where we're going to go into a word problem. A little bit more of a real life problem here. Everything Plumbing charges $46 for a service call, in addition to $18.50 per hour for labor. Plumbing Experts has no charge for a service call, but charges more, $30 per hour for labor. For what number of hours would both companies cost the same amount? So we want to write basically two expressions for Everything Plumbing. So I'll do Everything Plumbing and for Plumbing Experts. So Everything Plumbing, what's their charge? Well, they charge $46 every time, no matter what. But then they only charge $18.50 per hour, where H is the number of hours. So that's what we're looking for, number of hours. So that's going to be my variable. So that expression represents the total cost for Everything Plumbing. Plumbing Experts has no charge for a service call. So I don't have to put this, but I'm going to put 0 for the service call but they charge $30 per hour. So they charge more per hour. And we want to know when these two things are equal. So my equation is 46 plus 1850 H equals 30H, because 0 plus 30H is just 30H. So there's my equation. And I've got an equation with a variable on both sides. I'm going to subtract the 1850 H from both sides. So 30 minus 1850 is 1150 H. Divide by 1150, and you get 4. So what that means is, if the job is going to take 4 hours, these two companies are exactly the same cost. Now, let's interpret this a little bit. How much would it cost for that number of hours? Well, if it's $30 per hour and there's 4 hours, that would be $120 for everything, or for plumbing experts. What about for everything plumbing? Well, we should know it's going to be $120 because they're the same, but let's check just to make sure. 4 hours times $18.50 per hour is $74, plus 46 is $120. So regardless of who you choose, $120 for 4-hour job for each company. Which company would you choose if you had a job that would take 6 hours? So you could do what we just did above. 30 times 6. It's 180 for plumbing experts, or 46 plus 1850 times 6. So 1850 times 6 is 111, plus 46 is $157. So that would be, everything plumbing would be the cheaper route. So that would be the company you would want to choose for a 6-hour job. Okay. You could have also reasoned through that and said, well, it's more per hour for plumbing experts, so I'm going to go with the less per hour, because it's more, 6 hours is more than 4 hours, and I know at 4 hours is the same. So anything over 4 hours, plumbing experts is going to be more expensive. Anything under 4 hours, plumbing experts is going to be cheaper. Okay, so that's reasoning through some of the word problems. All right, last thing, special cases. Let's just do it and see what happens. So I'm going to distribute the 2. I'm going to get 6x minus 8 equals 6x plus 10. Then I'm going to subtract 6x from both sides. And look what happens. It cancels on both sides, and I'm left with negative 8 equals 10. Well, what do you notice? Well, the variables cancel on both sides. Because they cancel, you have 2 options here. The first one, the one we just did, we say this equation has no solutions. Because the remaining numbers are not equal. Basically, what this is saying is, if I put any number in for x, the 2 remain, it will not be equal, ever. Okay, let's look at the next one. X plus 3, so I'm going to distribute the 3. That's 3x minus 6 equals 4x minus 6. Combine like terms, x plus 3x is 4x minus 6 equals 4x minus 6. So we subtract 4x. They cancel, and I'm left with negative 6 equals negative 6, which is true, as opposed to the previous one where it was not true. So in this one, the variables canceled. We say this equation has infinitely many solutions. We will abbreviate that sometimes to IMS. But it has infinitely many solutions since the remaining numbers are equal. We have another name for this as well, and I'm going to write that down real quick. When you have infinitely many solutions, this equation is called an identity because the left side and the right side are identical. Think of it that way. All right, last problem is, looks like multiple choice. It's not really multiple choice. Circle the equations that have no solutions, underline the equations that have infinitely many solutions, and we'll go from there. So, first one, kind of quick here. If I subtract 7x from both sides, the variables cancel. I'm left with -1 equals +1, which is false. So this has no solutions. So it says circle the equations with no solutions. I'm going to circle that one. Next one, subtract 3x. 10x minus 3x is 7x plus 7 equals 7. Subtract 7. I get 7x equals 0. Divide by 7, I get x equals 0. Now, a lot of people think that that's a special case. It's not. X has a value. X equals 0. The variable didn't cancel here. This is not a special case. So I'm going to go ahead and answer that down here at the bottom. B is not a special case because the variable didn't cancel. What makes these special cases is the fact that the variables cancel. All right, C is another proportion. I'm going to do this a little quicker this time. I'm going to just cross multiply. So 2, make sure you include the parentheses, 2x minus 3 equals 4 parentheses x minus 6. Distribute, I get 4x minus 6 equals, distribute again, 4x minus 24. The 4x's are going to cancel here. And I'm left with -6 equals -24, which is not true. Therefore, this one also has no solutions. Last one, you can probably guess what's going to happen here, but let's just do it anyway. 3x plus 2x is 5x plus 4. Distribute the 4, I get 4x plus 4 plus x. So I'm going to add the 4x and x and get 5x plus 4 equals 5x plus 4. A lot of you, that's enough to see that these are identical on the left and right. So these are going to have infinitely many solutions. But if you want to keep going, you get 4 equals 4. So this is going to have infinitely many solutions. I'm going to underline this equation because that's what the directions said. And that is special cases. And that concludes lesson 2. In lesson 3, we are going to look at multiple variables and how to deal with that.